Systems of equations. Systems of equations consist of more than one equation. We're going to look at systems that have two equations. And when you solve a system, that means that the solution will satisfy each equation in the system. Now the process we're going to use is called substitution. If you know how to use elimination, by all means feel free to do so. With substitution, you basically substitute one equation to the other and solve for the variable. And we'll do some examples so you can see how this works. So look at this first example. If you notice this second equation, x equals negative 3y plus 3, is already has x equals. So what I'm going to do is I'm going to substitute this equation into that equation. So I'm going to rewrite the first equation just as it is. And notice that x equals negative 3y plus 3. So what that means is I'm going to substitute for the x. So I'm taking this whole equation, this negative 3y plus 3, and replace it for the x. So the second equation took the place of the x. So now what I have is an equation with nothing but y's in it. Now these parentheses aren't needed. I just put that in there so you can see that I substitute for the x. So what we're going to do is combine like terms. Negative 3y plus 4y is 1y, which is the same as a y. And then plus 3 equals 6. Then to solve for y, subtract 3 from both sides, and you get y equals 3. Now, to finish solving, I need a point, which is of the form x comma y. So what that means is I need to find x. Solve for x, find x, however you want to do it. And it doesn't matter which equation you use. I'm going to use the second equation because it's easier. And that's the only reason why. So what I'm going to do is I'm going to take the y that we found, which is positive 3. I'm going to substitute it. That's 3, by the way. And when we simplify, we get negative 9 plus 3. And negative 9 plus 3 is negative 6. What that means is our solution is negative 6 comma 3. And if you want to, you can check it right quickly. Negative 6 comma 3 into the other equation. 4 times 3 is 12. Negative 6 plus 12 is 6. So it does check out. Now, we're going to do some examples that have non-linear equations. Like this first one, x squared minus 6 equals y. That's a quadratic. It's a parabola, if you were to graph it. So what I'm going to do is, if you notice, this already has y equals. So I'm going to take this and substitute it into y there. So I'm going to take negative 2x plus y equals negative 7. Let me erase that. And I'm replacing the y, which is x squared minus 6, into the second equation. Now this is a quadratic. What that means is I want it to be in quadratic form. What that means is I need it to equal to 0. So what I'm going to do is I'm going to go ahead and add 7 to both sides. Those parentheses don't really mean anything in this problem. I'm going to write down the x squared first. That's my x squared, so my only x squared term. I'm writing down the minus 2x because I want it in correct order. And then minus 6 plus 7 is plus 1 equals 0. Now to solve this, you can use the quadratic formula, completing the square, but I'm actually going to factor. And if you know how to factor, that may be the best way. And factors is x minus 1, x minus 1. Since they're both the same, that means I only have to solve one of those equal to 0. And when I do so, I get x equals 1. So I'm going to go back up here. I'm going to write down x equals 1 so we can look at it. And now I need to find y. To do so, I can use either equation. I'm going to use the first one because it's actually a little bit easier to find my y. So I'm going to take the 1 and replace it for the x because that's what we found it to be. So 1 squared minus 6 equals y. And then 1 squared is 1. 1 minus 6 is negative 5, which means y is equal to negative 5, which means our solution is 1 comma negative 5. let's do this next one. Now this one, you'll notice we have all x squares and y squares. Now what I'm going to do, I'm going to take x squared plus y squared equals 12, and I'm going to solve for, it doesn't matter which one I solve for, x squared or y squared. I can use either equation. I'm just taking this first one mainly because it doesn't have any numbers in front of the x squared and the y squared. So I'm just going to solve it for x squared. It does not matter. And when I do that, that means I'm going to subtract y squared from both sides. And we end up with x squared equals 12 minus y squared. Now what I'm going to do is I'm going to substitute x squared equals 12 minus y squared into the second equation, into 2x squared plus 4y squared equals 56. So what that means is I'm going to take the 2x squared, and I'm not going to write x squared because I know what x squared is. It's 12 minus y squared. And so now I have an equation with all y's or y squares. So I'm going to substitute or distribute. We get 24 minus 2y squared, and then bring down the plus 4y squared equals 56. And we get 24 combined like terms plus 2y squared equals 56. Subtract 24 from both sides because I'm trying to solve for y, which means I have to get the y squared by itself first. We get 2y squared equals 32. Divide both sides by 2. We get y squared equals 16. And then we square root both sides. So when you do that, don't forget plus or minus. We end up with y equals plus or minus 4. So what that means is we now got to find x. And to find x, it doesn't matter which equation you use. You can use either the first one or the second one. I'm actually going to use the first one, but it's been rearranged in this form. So I'm going to use that equation. X squared equals 12 minus y squared. X squared equals 12 minus y squared. So what I'm going to do is I'm going to substitute y equals 4 first. The positive 4. So when I do that, we're going to get x squared equals 12 minus 4 squared. And then we get x squared equals 12 minus 4 squared is 16. We get x squared equals negative 4. And then we get x equals, well, I better show you the steps. We square root both sides. Don't forget plus or minus. Now I gotta come down here. And I need some space. And so, plus or minus square root of 4 is actually plus or minus 2y. Now, what that means is, notice what we substituted. We substituted 4 in. Now let me show you something else right quickly, just to save some writing. I also need to take the negative 4 and substitute for the y, so I can find out what x squared is, because actually I have two different y values, plus 4 or negative 4. If I were to go ahead and substitute the negative 4 in, when you square a negative 4, you still get a positive, or a positive 16. That minus sign is with that minus sign. So in other words, we're going to get the same result. So in other words, we have two different y values, plus or minus 4, And when we get done solving for x, we have two different x values, plus 2i or negative 2i. So what that means is I need to list all combinations for those. So my points are 2i comma 4, 2i comma negative 4, negative 2i 4, and negative 2i negative 4. There's my 4 solutions. And now let's do this last one. Notice on this one that we have actually binomial squared, which is going to make a big difference. Now I'm still going to use substitution, but before I can do that, none of these variables are isolated. So what I'm going to do is I'm going to take y minus 2 equals x minus 3 squared. And I'm going to solve for y, because that's fairly easy to do. That just means get the y by itself. I could do the same thing on the second equation. It doesn't matter. This one is actually a little bit safer because when I solve for y, I'm going to add 2, which means I don't have as many negative signs to worry about. And so, now what I want to do, I'm going to take the y plus 6 equals x plus 1 squared. And there's different approaches that you could take on this. You could actually go ahead and solve this one for y, and then set these two equal to each other if you wanted to. That's fine also. All I'm going to do is take this equation and I'm going to substitute it for the y in this one. So what that means is I'm going to take x minus 3 squared plus 2. So all of that is my y. And then this here, all that is my y. And I still have my plus 6 that I have to bring down. Then I bring down my right side. From here I'm going to clean it all up. This x minus 3 squared is the same as x minus 3 times x minus 3. I'm going to fold that out. So you get x squared minus 3x plus 9. I'm going to go ahead and add the 2 and the 6 together, which is a plus 8. And then this x plus 1 squared is the same as x plus 1 times x plus 1. I'm going to fold that out. So we get x squared plus 1x plus 1x plus 1, because 1 times 1 is 1. Now I want you to be aware of something right quickly. If I subtract out this x squared, what that does is it eliminates both of those. So now I'm going to combine like terms on both sides. So I have negative 6x plus 17 on the left side. On the right side I have 2x plus 1. And it's a good thing those x squares cancel, because that means this is a much easier problem to solve. So what I'm going to do is I'm going to add 6x to both sides. I'm going to go ahead and subtract the 1 from both sides. And we get 16 equals 8x. And then I'm going to divide both sides by 8. And we end up with x equals 2. So now, which is good, because that's a nice number to end up with. Now we're going to find y. And it doesn't matter which one you use. I want to use the second one because it doesn't have any minus signs in it. It doesn't really matter though. So y plus 6 equals x plus 1 squared. Y plus 6. Yep, if my thing will cooperate. Equals x plus 1 squared. I may not need all that. Let's make sure. Y plus 6 equals x plus 1 squared. I'm going to erase these parentheses. We don't need those. That might bother some people. So everywhere I have an x, I'm going to put a 2. And solve for y. 2 plus 1 squared. Y plus 6 equals 3 squared. 3 squared is 9. Subtract 6. Y equals 3. So we had x is 2, y is 3, and our solution